Hello everyone, in this video we are going to solve a very interesting problem inspired by Stranger Things, where Joyce uses a string of alphabet lights to communicate with Will trapped in the Upside Down. The problem is based on a fixed keyboard layout and a signal that gets shifted either to the left or to the right. Let's understand how to decode the original message step by step. First, the problem statement. During Christmas in Hawkins, Joyce uses a string of alphabet lights to communicate with Will, who is trapped in the Upside Down. Each light corresponds to a letter arranged in the following fixed order. The order is this. Due to a strong interference from the Upside Down, the signal shifts exactly one position to the left or to the right every time Will blinks the light. As a result, Joyce sees a neighboring light instead of the one Will actually intended to blink. You are given the direction of the signal shift and the sequence of lights Joyce observed. Your task is to decode the original message Will wanted to send. The input format for the question is as follows. The first line contains a single character, L, if shifted his hand to the left, or R, if shifted his hand to the right. That means this represents the signal shift. The second line contains a string S that represents the sequence of light blinking that Joyce observed. The constraints that we have to keep in mind is that the length of the S must range from 1 to 100. The string contains only characters present on the keyboard, and it is guaranteed that all pressed keys are valid. The output format will be the program will print a single string representing the original message from the Upside Down. If we take an example, the first the first letter obviously represents the signal shift, and then the second string represents the light blinking observed by the Joyce, and the output will be the message that Will actually intended to send. The most important observation in this problem is that the keyboard layout is fixed and ordered. So if the shift direction is R, it means that Will's hand was shifted to the right and Joyce observes the letter to the right of the intended one. For example, if Will wanted to send letter A and the shift direction was R or right, what Joyce would observe is letter S. So to recover the original key, what we must do is we must shift one position to the left so that we can get the actual letter. In a similar fashion, if the shift direction was L, so suppose it was L. So what happens is what it means that the Will's hand was shifted to the left, and Joyce would observe the letter left to the actual intended one. In the same example, we'll say that if Will wanted to send letter A and the shift direction was L, what Joyce would observe is letter P. To recover the original letter, we have to shift one position to the right, so we'll acquire the actual intended letter, that is letter A. So the idea is very simple that we have to reverse the shift. Let's talk about the approach of the problem using the example given. So first, what we'll do is we'll store the entire keyboard layout in a variable. After that, we'll take the string that was observed by Joyce, which in this case is this, and then take each individual letter. First, we'll take S. We'll find its position in the keyboard layout. Observe the shift direction. In this case, that's R, or we can say right, and we'll reverse the shift. So what do you mean by that? Is that we'll shift one position to the left to gain the to acquire the actual letter. So in this case, the first letter was S. Will we observe the direction that is R? We shift one position to the left, and we acquire the actual letter that is A. So if we to update it here, A. In a similar way, what we'll do is we'll take the next letter in the string, that is this, will find it in the keyboard layout, again check the direction, and then reverse it. That is to move one position to the left. The If we do the same process, what we are getting is the letter L, and then adding that letter to the actual string in such way that we have to iterate over the entire string, keeping in mind the direction, and then storing the actual string in another variable. Now let us walk through the code of the problem. We are using the variable char dir will store the shift direction of Will's hand, and string s will be used to store the string observed by Joyce. Using the functions cin will take the input from user and store them in variable dir and s. User will input two strings. The first would denote the string direction, the shift direction, and the second would be the string observed. Another variable called keyboard of data type string be used to store the fixed and ordered keyboard format. String ANS will be used to store the actual intended string that the will wanted to convey. Using the for loop will iterate over each individual character in string S. For each character, we'll find its index in variable keyboard using the function find, and then store it in int idx. Now, depending on the direction, we'll reverse it. If the direction is left, will what we'll do? Will be appending the character at index plus one in the string keyboard into the variable ans. Else, that is, if dir equal to r, what we'll do is we'll be appending into the variable ans the character that is present in the string keyboard at idx minus 1. At last, will give the output that will contain the actual intended string. That's going to be the end of program. We'll run the code. The code has successfully passed the sample test case. We'll now submit it. The code has passed all this test case successfully. Now to discuss the complex analysis of this program, we'll see that the time complexity is big O of n, and the space complexity is big O of 1. This solution works because the keyboard layout preserves the exact adjacency of key. Since the program guarantees all the pressed keys are valid, we never go out of bounds. Therefore, the algorithm always reconstructs the original message correctly. So that's it for the problem. Thank you so much.